Today we're gonna talk about identifying compounds through chemical and physical changes. This is experiment 2, and this is the lab that you're going to be conducting on Friday. So what we're going to learn in this video are a few things. Number one, we're going to learn the difference in a chemical and a physical change, which you probably already know, but it's always good to refresh. We're going to learn some clues that indicate chemical changes are occurring, and then how to test unknowns by using knowns and determining what an unknown is. All right. So, what's a physical change? It's a change that occurs to the physical structure without modifying the chemical makeup. Right. Every physical change is reversible. If you think about a vase breaking, if you drop a vase on the ground and shatter it into a million pieces, if you find every piece, you can put that vase back together because it was only changed physically. So state changes are considered physical changes, like going from water to steam, or from water to ice, right? From a solid to a liquid, or from a liquid to a gas. That's a physical change because at the end of the day, you haven't changed the molecular structure or the chemical makeup of that particular compound, right? If you take a sandwich, see this little kid enjoying this nice big sandwich, um, chewing the sandwich up is a physical change, right? Putting the bread and the meat and the lettuce in your mouth and chewing it up is a physical change. Now, it might be difficult to put the sandwich back together afterwards, but you can. Now, once the bread and the meat and the lettuce starts to become digested, and when the chemicals in your body, the acid in your stomach and things like that start working on that sandwich, then it undergoes a chemical change because there's a reaction happening between the chemicals in your body and the contents that make the meat or the lettuce or the bread up, right? Physical change, again, only occurs to the physical structure. So if you take bricks and you crush them up, that's a physical change, right? Even though the pieces may be small, it may look like fine dust at some point. If you get the pieces back together and you reconstitute the pieces, you can get the brick back because, again, every physical change is reversible. So again, just to reiterate the definition, a physical change happens and it only alters the physical structure. The atomic or molecular structure does not get touched. And also physical changes are reversible, right? What's a chemical change? A chemical change is a change that occurs to the fundamental chemical makeup of a thing, of an object, of anything, right? And a chemical change is irreversible, right? So again, you saw the sandwich, the kid eating the sandwich, that kid was enjoying that sandwich, and the sandwich was physically uh, changed by being chewed up. But then when that sandwich went down into the belly, then it becomes chemically changed because the chemicals in the body start working on it. So here's another example. So here's a burger that goes down, and once it goes down into the gut, right, that burger dissolves and the proteins get absorbed and the carbohydrates get absorbed and all of that. And so what we're looking at again is a chemical change. It occurs and it changes the fundamental chemical makeup. You go from one particular molecule, it gets reacted on and it becomes another molecule, and that's irreversible, right? If you take sand from the beach, right, you dig it up from the beach and you take it home, that's a physical change. If you beat on it with a hammer, it's a physical change. But when you put the sand and add some additives to it and put it into a furnace, right, and you heat it, the heat causes a chemical change, and that's where we get glass from. You can see the little champagne glass over here. And so, again, chemical change changes the chemical and molecular and atomic makeup of a thing, but a physical change does not. Physical change just changes the physical structure, right? So here's the definition, just to reiterate. You alter the atomic and molecular structure, and it's irreversible. Once a chemical change happens, you can't go back, right? So how can we tell if a chemical change is happening? Number one, you can look for gas evolution, right? You can look to see if bubbles are evolving from the solution, right? You add in, you mix two chemicals and you see gas coming off the solution or bubbles coming off the solution, then you know that it's a chemical change. You feel for temperature changes, right? If the temperature goes up or goes down, you know that there's a chemical change that's happening. If the color changes, right? If the color changes, you know that a chemical change has occurred. Um, if the smell changes, right, you know that a chemical change has occurred because normally a smell is associated with gas being involved. If you form a precipitate, right, you know that a chemical change has occurred. When you mix two chemicals together and you get a precipitate that forms, then you know a chemical change has happened. So these are the codes we're going to use when you write in your lab book. If you see a precipitate forming and it's colored, you say, or it color change and a precipitate, you say PC. If you see the solution turn cloudy and there's a color change, you use the term or the code CC. If there's no reaction, like you see nothing, right? If it's clear when you start and clear when you end, no gas bubbles, no heat, no anything, then you just write no reaction or NR. If you see a gas that comes off with no odor, then you write G. If gas comes off and you smell something different, then you write GO. And then if it's colorless, but you know that something happened, maybe a temperature drop or a temperature increase or something like that, then you'll write that as the code colorless, right? So what is all this leading us up to? Well, you're going to have some known compounds that you're going to use, and you're going to test those known compounds with a particular test to look for a chemical reaction. So when you test your known, right, with a particular compound, right, and the color changes of the known after you add in the test additive, and then you have an unknown that you don't know, but you add the same additive to that unknown, right? You see the color change is the same. Both liquids turn blue. So what that means is that whatever the known compound is here is probably what your unknown compound is here. That's how you're able to test known compounds and then extrapolate the data from the known compounds to determine what the unknown compound is. So when you observe something with a known compound, it makes it possible to determine the identity of an unknown compound. So to this experiment, experiment 2, we have known compounds: sodium chloride, sodium carbonate, mag sulfate, ammonium chloride, and water. And when you add silver nitrate to each one of these, something is going to happen. You're either going to get a precipitate, you're going to get a color change, you're going to get gas evolution. Something is going to happen, right? And so when you test with silver nitrate, this is one of your 3 different tests. When you add silver nitrate to any of these 5 compounds, you're going to observe something that happens, right? I can tell you up front that when you react silver nitrate with sodium chloride, you're going to get sodium nitrate and silver chloride is insoluble in water, so you're going to get a precipitate, right? So you're going to add silver nitrate, and then the next test on the known compounds will be to add sodium hydroxide, and then the next test will be to add HCl, and each one of these tests is going to give you something that you can use to identify an unknown compound. So what are you looking for? You're looking for the changes that we talked about, right? Did the solution heat up? Did it give off gas? Did the color change? Did you form a precipitate? Did the temperature change? Any of these things that happen, you know that there was a chemical change that occurred. And when you analyze the unknown, what you want to do is use what you know about the known compounds to determine what you don't know about the unknown. So if you have any questions, you can email me, you can call me, or you can drop by the office in Armstrong 102. Thanks.